Hello everyone. Thank you for being here. We are looking at basic concepts of ratio and proportion in today's video. This is an important topic for all competitive examinations because to do well in other areas of quantitative aptitude like say time and work, time and distance or whatever, you need to have a clear understanding of this topic, ratio and proportion. Ratio is a concept used to compare two or more comparable quantities. For example, if I say 2 is to 3, generally this is the way, as you know, ratio is represented. Ratio of salaries of two people, say A and B, then what does it mean? It means rather it helps us get some possible values for their salaries. For example, A salary can be 2000, B can have 3000, or A can have say 20,000, and in that case B will have 30,000. Or it could be 200, 300, 2 lakh, 3 lakh. That way it goes. Say 2 lakh, 3 lakh. It gives a relationship between the salaries of these two people, but we don't get the correct salaries of these two people. Ratio gives you a comparative position of two people with reference to their salaries or whatever, and it can be extended to even more than two people, but it does not give you a correct picture, or rather, we are unable to find out the correct salaries of these two people. So, in brief, you can say that A has a salary of, if you go through all these figures, they are all multiples of 2 and 3. A salary will be a multiple of 2. You can write it as 2 multiplied by x, and B salary will be 3 multiplied by x. Where x is what? We don't know. Supposing you know some additional information like total salary of A and B, let it be 10,000 rupees. In that case, we will be able to find out the correct salaries of A and B. When I say 10,000 is the total salary of A and B, see, total salary of A and B you can write as 2x plus 3x from the ratio figure 2 is to 3. And this would be the total salary. And that's given to be 10,000. Now look at this. It reduces to a very simple equation. 2x plus 3x, 5x equals 10,000. Taking 5 to the other side, 10,000 divided by 5, you get 2,000. So you got the value of this multiple, x. Now salary of A will be 2 multiplied by 2,000, which is 4,000. Similarly, B salary will be 3 multiplied by 2,000, which is 6,000. This is the basic nature of most of the problems in ratio. You will be given a ratio and you will be given some additional information to find out the multiple figure like this. So this is the way to approach a problem using the basic definition of ratio. For simple problems of this kind to find out the individual salaries of A and B, you don't need to take this approach. Look at this. 10,000 is given to be the total salary. When you say the ratio of their salaries is 2 is to 3, the meaning of this is when the total salary is 5, A will have 2 parts of that and B will have 3 parts of that. Rather, when the total salary is 5 rupees, A gets 2 rupees, B gets 3 rupees. So when the total salary is 1 rupee, how much does A get? 2 divided by 5. We are using the unitary principle. And what about the salary of B? Total salary 5, B gets 3. When total salary is 1, B will get 3 divided by 5. See, generally, what do? If you know the cost of 5 pence, 2 rupees, then what would be the cost of 1 pen? 2 divided by 5. Exactly the same principle I have used here. And this is called unitary principle, which we apply a lot in arithmetical problems. Now, if the total salary is 1, A gets 2 divided by 5. If the total salary of 10,000, how much does A get? 10,000 multiplied by 2 over 5. Similarly, B will get 10,000 multiplied by 3 over 5. This on simplification is 4,000. And this is the figure given here. Again, this on simplification 6,000. This is the figure given here. So you don't need to take the definition of ratio in simple problems. You may take this approach. Many people know how to divide 10,000 into ratio 2 is to 3. When you divide, this is what you write, the salary of A, and this is what the salary of B. But most people don't know how they get 2 over 5 and 3 over 5. And that meaning is what I'm trying to give you through these different ways. I hope you understood the correct meaning of ratio. See, competitive exams throw up challenging problems which you can tackle if you're familiar with the basic concepts. Shortcuts are fine, but the basic concepts are also equally important. Now, in the discussion of ratio, I've considered only two quantities. You can extend this to, supposing you have, say, 4 people, A, B, C, D. And if I say they have their weights in the ratio 2 is to 3 is to 4 is to 5, what would be the meaning? The weight of A will be 2x, that of B will be 3x, that of C will be 4x, and the last one will be 5x. Where x is what? We don't know. To find out x, there will be some other information provided in the problem using which you can correctly find out value of x. There is one more thing I would like to discuss with you. Supposing you're given a ratio like 2 is to 3, that's nothing but 2 divided by 3. Ratio and fraction, they are the same. Now let's look at a few simple problems to understand the basic concepts of ratio. The first one. Supposing I say A is to B equals 3 is to 4, then find the value of this algebraic expression 2A plus 3B divided by 5A minus 2B. Yeah, here we will use the basic definition of ratio. This ratio means A is 3x and B is 4x. Then you substitute 3x and 4x in the required expression. So here, what do you have? 2 multiplied by 3x. See, A is equal to 3x. Plus 3 multiplied by 4x. Divided by 5 multiplied by 3x. Minus 2 multiplied by 4x. See, this is 6x. This is 12x. So sum of these two will be 18x. This is 15x minus 8x. 15 minus 8, 7. So 7x. These two x's will cancel and you will get 18 by 7 as the value of this expression. Now to simplify this, you may avoid using x, which is not always correct, but in this case it will be okay because the numerator is a first degree polynomial. I mean the power of a and b 1 1. Denominator also the power is 1 and 1. So instead of bringing in x, to simplify this way you can do. 2 multiplied by a you can take as 3, b 4 divided by 5 multiplied by 3, 2 multiplied by 4. On simplifying, you will get straight away 18 divided by 7. Keep in mind, here you are taking a as 3. That's only a possible value. That's not the correct value. But for this purpose, it won't create any problems. You will get the answer correctly. But if you take this way, in other problems, there are certain problems, where you can't take a as 3 and b as 4. You should take a as 3x and b as 4x. Let's look at a problem that's slightly different from this. For the same problem, let's find out the value of this expression. A square plus b square divided by a plus b. Here, don't substitute a as 3 and b as 4. You will take a as 3x and b as 4x. The reason is this. Numerator is a second degree expression and the denominator is a first degree expression, which is different from the previous problem we worked out. So here you will have a 3x the whole square plus 4x the whole square divided by 3x plus 4x. And this will be 9x square. This will be 16x square. So what do you have? 9 plus 16, 25. And you get 25x square divided by, this is 7x. On simplification, you will get 25 divided by 7. See, x square by x is x. That x is left over here. So what is the value of this expression? You are getting in terms of x, which we don't know. So basically we say this expression cannot be determined as a constant number using this information. Whereas if you substitute directly a equal to 3 and b equal to 3 in this expression, what would you get? you will be getting, so let me write it here. If you're doing it that way, a square plus b square, a plus b, actually this is wrong. So let me put this is not equal to 3 squared plus 4 squared. These are just two possible values of a and b, and the denominator will be 3 plus 4. On simplifying, you get it as 25 by 7, which is wrong. So never do that in this case. But here it is okay. I hope you have understood the meaning. If you are in confusion when to avoid x or when not to avoid x, you go by this. Whereas if you can understand the basic principle correctly and the correct distinction between two different problems, and if you can figure out where to use which, go by constant numbers or variables as the case may be. Now let's look at another problem. A is to b equals 5 is to 2. Find the value of this algebraic expression. A squared plus b squared plus 2ab divided by a squared minus b squared. If you look at this problem, both the numerator and the denominator are of second degree polynomials. In such cases, you may take a as just 5 and b as 2 and then substitute and simplify. You will get the value. So putting a equals 5, you get 5 squared plus b2, 2 squared plus 2 multiplied by 5 multiplied by 2, the whole divided by 5 squared minus 2 squared. This equals is 25, 4, 29. This on simplifying 20, the whole divided by 25 minus 4 equals 49 divided by 21. If you apply the precise definition of the ratio, this would be a equals 5x and b equals 2x. But when substituted here, you will get x squared in the numerator and x squared in the denominator, and they will cancel out. So it doesn't make any difference whether you take a as 5 and b as 2 or multiples of 5 and 2. In fact, there is a slightly different approach which would be even shorter than this. If you look at these algebraic expressions, you can see it's an identity. The numerator is nothing but a plus b, the whole square. And the denominator is squared minus b squared is a plus b multiplied by a minus b. This one is a plus b multiplied by a plus b divided by a plus b multiplied by a minus b. These two you can cancel and you will get a plus b divided by a minus b. And then you substitute a as 5 and b as 2. You get 5 plus 2, 5 minus 2 equals 7 by 3. In fact, this we could have simplified further. 49 and 21, 7 is common and you will get 7 over 3. See, you're getting the same answer. Now there is an idea in ratio where you combine 2, 3 ratios, 2, 3, 4, any number of ratios into a single ratio. Let me illustrate that with a simple problem. Supposing A is to B equal to 3 is to 5, B is to C equals 4 is to 3, then find the value of A is to B is to C. This is what I meant by combining ratios. You are given two separate ratios and then you are finding a single ratio like A is to B is to C, combining these two. A is to B, 3 is to 5. Let me write it again. And B is to C, 4 is to 3. See, you can't compare linearly because B is common in the ratio, but B values are different. Here B is 5, here B is 4. So generally what we do is convert these values into a common value, which is normally the LCM of these two. What is the LCM of 5 and 4? 20. So what we do is bring 20 here, the first ratio, without changing its value. So how do you do that? A is to be 3 is to 5 means that is 3 divided by 5, this ratio. If you multiply the numerator and denominator by any number, the value will not change. Let me multiply by 4. 4 I am choosing because you will be getting 20. This is 12 by 20. So 3 is to 5 is same as 12 is to 20. You don't need to write those steps. You multiply both the terms of the ratio by the same number, which in this case 4. What do you do with the second ratio? You will multiply both the terms by 5. Then only you will be getting B as 20. So multiplying by 5, 4 multiplied by 5, 20. 3 multiplied by 5, 15. Now you can combine. See, we got the value of B equalized. Then you can write A is to B is to C as a 12 is to 20 is to 15. Now there is a shorter way to do this. Look at this. A is to B given as 3 is to 5. B is to C 4 is to 3. So to get this ratio, what we do is you multiply like this. Then you multiply like this. 4 and 5. Then you multiply 5 and 3. So when you multiply 3 by 4, you get 12. When you do this sort of multiplication, you get 20. And this one, 15. This is a shorter way to get to the value of A is to B is to C. If you are given A is to B as some ratio and B is to C some other ratio. This is what I meant by combining two or more ratios. See, here I have taken only two ratios. You can extend this to even three ratios. We'll do as the next problem. Let me use the same figures. A is to B, 3 is to 5, B is to C, 4 is to 3. Then let me introduce one more ratio. C is to D, 6 is to 7. And let's find out A is to B is to C is to D. Given three ratios, you're combining into one ratio like A is to B is to C is to D. What we can do is combining the first two ratios and you find out A is to B is to C, which we have already done. So let me begin here. Okay, see, A is to B is to C. Since you have found it out before, I'm using those figures. And that is the first step. Given three ratios, take the first two, combine, you find out this. After that, you write C is to D below this one. See, this is the other ratio given. You write it like this. You can see C being common here in these two ratios. So like I said before, you will equalize the value of C. Take the LCM of 15 and 6. What is the LCM? 30. See, even if you choose the next multiple, nothing wrong. You will get the correct answer. You will get 30 instead of 15 here and 30 instead of 6 here. So, how do you bring 30 here? You multiply this ratio throughout by 2. That ratio will not change. I have shown that before. So you get 24, 12 into 2, 24, 20 into 2, 40, 15 into 2, 30. Now how do you bring 30 here? Multiply both the terms of this ratio by 5. So 6 multiplied by 5, 30. Then 7 multiplied by 5, 35. Now you can combine. You have equalized the value of C. So A is to B is to, this is the thing to be found out. So you can write 24 is to 40 is to 30 is to 35. This is the method of combining any number of ratios. By the way, when you have three ratios, this shortcut won't work. This is the way to go about and get to the final answer. And there is a different approach, which some people think shorter than this, but I don't know. I'll show you that here. You decide which one you want to use. In the next method, you write A, B, C, D like this. A is to be given to be 3 is to 5. So you write those numbers here, 3 and 5. And then B is to C, 4 is to 3. You write below this number 4 and C, 3. Then C is to D given to be 6 is to 7. You will be writing 6 here and 7 here. That is the first term. Then there are some blank spaces here. Here, 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 and here. There are totally 6 blank spaces. So here you will be writing, since these blank spaces are right to 5, you will be writing 5 and 5. And here, one blank space here, one blank space here. This is before 4, so you will be writing, 4 here. And this is after 3, so you will be writing 3. Okay. To the right, you write this number. To the left, you write this number. Again, these two blank spaces, both of them to the left of 6. So, both will be 6. And then you multiply like this. 72. 3 multiplied by 4, 12. 12 into 6, 72. Then 5 multiplied by 4, 20. 20 multiplied by 6, 120. Then 5, 3, 6. That will be 90. 537, product will be 105. And this will be the ratio. It's not the final answer because you can see some number dividing all of them. I think 3 will go in all the numbers. So dividing all of them by 3, this will be 24. 120 divided by 3, 40. 90 divided by 3, 30. 105 divided by 3, 35. And this is the answer we had here. So this is the other method. I have walked you through both the methods. I don't know which one is shorter. You decide and try which one you like. I'm leaving it to you. Now, generally, the components or the terms of a ratio are whole numbers. But there are cases when you have these components. See, the meaning of the terms of a ratio is, see, if you take A is to B is to C is to D, these are the 4 components or these are the 4 terms. Okay, these terms can be decimal numbers or fractions. For example, supposing you are given a ratio like, let me write it as the 5th problem. 1 over 2 is to 1 over 3 is to, not necessarily 1, you can have any number. See, let me write something else. Say 2 and let me write 4. Any number is okay, any fraction. Okay, so there are 3 terms in this ratio and each one is a fraction. 1 over 2, 2 over 3, 4 over 5. So how to convert this into a ratio? With positive integers. Look at the denominators 2, 3, 5. Take the LCM of 2, 3, 5. What is the LCM? 30. Multiply the 3 terms of the ratio by this number 30. As I said before, if you multiply a ratio by the same number or if you divide a ratio by the same number, the ratio will remain the same. So multiplying the first one, 30 multiplied by 1 over 2, 30 multiplied by 2 over 3, 30 multiplied by 4 over 5. This cancelled, you will be getting 15. This cancellation gives you what? 10. 10 multiplied by 2, 20. Here it goes 6 times. And 6 multiplied by 4, 24. This is how you convert a ratio with fractional terms into a ratio with positive integers. By the way, if you have only 2 terms in a ratio, for example, 1 over 2 and say 4 over 5, you don't need to take this approach. You multiply like this, cross multiplication like, that's 5. Then you multiply this way, 2 multiplied by 4, 8. Immediately you can write the answer. But this works only for 2 terms, not for 3 or more number of terms. Actually, how do you get it? See, what is the meaning of this? I'll show you the basic idea here. 1 over 2 is to 4 over 5. The meaning is A is to B means A divided by B. So what do you have? 1 over 2. This is the meaning actually, 4 over 5. And to divide a fraction by another fraction, you take the reciprocal of the second fraction, which is 5 by 4. Now on simplifying, what do you have? 5 over 8. Can you see that? And that's what I've written here. You don't need to do all these roundabout steps. Cross multiply like this, 1 into 5, then cross multiply like this, 8. You're right, that is the answer. But it works only for 2 terms. If you have 3 terms, take the LCM, multiply throughout by, you will get it converted. That's all. Now, what do you do if the terms are in decimal numbers? We will look at one more case and wind up the video. See, for example, supposing you have a ratio like this, 3.9 is to 7.8. In the first step, you multiply both the terms by 10. You will have 39 is to 78. But there is something common here. I think 13 will go in both. Number 13. So 13 will go 3 times and 13 will go 6 times here. Again, you can write like this. 1 is to 2. That's all. When you have decimal numbers as the different terms of a ratio, this is the way to go about and convert it into ratio of positive integers. This video is a bit lengthy, so I'm unable to get to the concept of proportion, which I will do in my next video. And also I'll be covering a few word problems, making use of all the basic concepts we have done in today's video. So please subscribe to my channel and press the bell icon so as not to miss out on the other videos. By the way, if you have learned something useful in today's session, please like and share the video. Thanks for watching and see you in the next video.